Okay, so we're going to start chapter 7 today, and that's going to be exponential functions today, and then we're going to get into logarithms. That's where you're really going to have to majorly pay attention to the properties and what you're doing. Okay, so today is just exponential growth and decay. We're going to graph it, we're going to look at the transformations, and then we're going to do some word problems that you have to determine if it's a growth or a decay, so you know how to use the right formula. So your exponential function is a function in the form f of x equals a times b raised to the x power. So that x as your exponent is only affecting what's directly in front. That is not affecting the a times b. It's only affecting the b. Okay? Where b is your base and it's a positive real number other than 1. For you to have a growth, what mainly happens is this b, your base, is greater than 1 for it to be a growth. Okay? A's got to be greater than 0. B has to be greater than 1. B is...
Sorry, do I do long division and stuff like
No,
that?
you do not do 1 or 0.
Okay.
Okay, so b is your growth factor. The simplest type of an exponential growth function has the form f of x equals b to the x. So there's that's your parent function. Okay. For the exponential growth parent function, your graph looks like this. Okay, it starts off really steady and then it goes up exponentially. So that's your exponential growth. It's going to pass through 0, 1, and then whatever your base is, it's going to be 1b. So it's going to pass through those 2 points no matter what. Now you're going to have an asymptote. An asymptote is a line that your graph approaches but never actually crosses. Okay? So we're going to be drawing the function along with the asymptote. So you're going to have a horizontal asymptote for each exponential function that you have. So for the parent function, the x-axis is your horizontal asymptote. So we abbreviate it HA. So I'm not going to tell you x-axis. My horizontal asymptote is not the x-axis. It's, as an equation, y equals 0. Okay, now my domain, I'm going from negative infinity to positive infinity, but my range, I'm not going past that asymptote. So I'm going to go from 0 to positive infinity for my y values. That's going to be my range. Now pay attention that I'm not going to have a bracket because it never actually equals that 0. It just gets really, 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 really close to it, but it's not going to actually equal it. Okay? Now for a decay, you're going to start leveling out. Instead of starting leveled out, you're going to end up leveling out. And this is going to be where your base b is between 0 and 1, so a decimal or a fraction less than 1. Okay? So it just flips the way that it's going down, so it's decaying. You still have the x-axis as the asymptote, so your horizontal asymptote is still going to be y equals 0 for that parent function, even though it's a decay. And you're still passing 0, 1, and 1b. Okay? Your domain here is still going to be negative infinity to infinity. Your range is still going from 0 up to positive infinity. Okay? So, if I'm just telling you to graph f of x equals 2 to the x power, my x values are going to be the same, negative 2, negative 1, 0, 1, 2. Alright, then for my y, I'm doing 2 raised to the x power. I'm just plugging those values in as the exponent. Okay, so you don't need the graphing calculator because on this calculator you can still take 2 raised to the negative 2 power. You get 1/4. Alright, I don't care if you put 1/4 or if you put 0.25. Then you're going to do that all the way through. So 2 raised to the negative 1 is going to be 1/2. Or if you put 0.5, that's okay too. 2 raised to the 0 power is just 1. Anything raised to the 0 power is 1. That's why you're going to always go through 0, 1. Okay? Now, If I have 2 to the first power, that's just 2. So that's my 1b. And then 2 to the second power is 4. Okay? So I'm going to graph this, but what is going to be my asymptote that I'm not going to cross, that I have to graph? If I'm going from -2 to 0.25, -1 to 1/2, 0, 1, 1, 2, 2, 4, I'm approaching what y value? 0. So my graph is going to look like that, but I have to draw that asymptote. If you have to do it with a different color, that's fine. If you need to go a little above or a little below so that I can tell that you graphed that asymptote, then that's fine too. So for an exponential function, you have to graph your asymptote. So my asymptote here we said was y equals 0. My domain is going to go from -infinity to infinity. My range, I'm going from 0 up to positive infinity. And that's all I need to do for that. I didn't have any transformations there. Y'all good with that? Okay. Now your transformations. This is like the 3rd time we're going to do transformations, so you should be familiar with everything. I'm not going to break this whole table down because the only thing that has changed are these examples. We've done it with quadratics, we've done it with cubics. So just pay attention. If it happens to the x, it's going to happen in that exponent. If it's not in the exponent, then it's not happening to x. Okay? Everything else would be y. So if I am shifting it up or down, that is when your horizontal asymptote will equal that k value. So if I have 2 to the x power plus 5, my horizontal asymptote is going to be y equals 5. So whatever that k value is that you're adding or subtracting, that's going to be your new horizontal asymptote. A reflection, remember that if it happens to the x, you're really flipping over the y-axis. But do not make the mistake of telling me flips on a test or a quiz. You have to use the actual terminology, reflection. I got that on one of the tests, and you got 0.2 seconds off because that's not mathematically correct for the transformation. You've got to tell me reflects. So if it happens outside of the exponent, so it's happening to your y, remember that it's reflecting over your x-axis, so that those two are flipped. Horizontal, remember everything is basically a reciprocal when it comes to stretches and shrinks. Vertical is as is. So if you have a number now multiplied to that base raised to the x power, that's your stretch or shrink. Your y-intercept is going to change, and it's going to be whatever that a value is. So that's only if you have something multiplied. I've already said the horizontal asymptote is going to be whatever your k is. So if I have y equals a times b to the x plus k, whatever that is going to be your new horizontal asymptote. Okay? So on the notes, we're going to be graphing it, but you do have a section on your worksheet where without graphing it, you have to identify the transformations. I didn't feel like y'all really needed that in the notes because this is like the 3rd or 4th time we've been identifying transformations. But we can go back and look at what would happen. Okay, so for the following functions, tell whether the graph represents a growth or a decay. Make a t-chart, graph the functions, state the equation of the asymptote, transformations, domain, and range. Okay, so whenever I have my tables, okay, I'm going to do my parent first. My parent function is just going to be whatever the base is raised to the x. So I'm going to have 4 raised to the x power. Now remember that base is what indicates if it's a growth or a decay. That base is a 4. Is this going to be a growth or a decay? It's going to be a growth because it's more than 1. Okay. My x values are still going to be -2, -1, 0, 1, 2. Now 4 raised to the -2 power is going to give me what? 1/16. As a decimal, what is that? Because if you plug it in here, this is going to be, it's going to give you 4 raised to the -2. It gives you the decimal. Well, no, it doesn't. So if you want the decimal so you know how to graph it, do second and then that fraction. So if you would rather do decimals in your table, that's fine. You've got to graph that either way. Okay? You should know, though, that's like really, really close to 0. So you don't have to convert it to a decimal if you know that's really close to 0. Okay? Now, 4 to the -1 is 1/4. 4 to the 0, 1. 4 to the first, 4. 4 to the second, 16. Okay, I'm not going to graph that one. We've done enough graphing parent versus transformation. I'm only going to graph this transformation one. Okay? Now, is anything happening to my x? No. So my x's stay the same, -2, -1, 0, 1, 2. But for my y, what am I going to have here? 1/2 y. So 1/16 times 1/2 is going to give me 1/4 times 1/2, 1/8. Then I'm going to have 1/2. Then I'm going to have 2. Then I'm going to have 8. Okay, do I have anything added or subtracted behind this exponent part? No. So is my horizontal asymptote going to shift any? No. I'm still going to have my horizontal asymptote at y = 0. So just get as close to 0 as you can for those two first points for when x = -2 and x = -1. If you overlap, like if you cross over that asymptote that you drew, you will get points off because you have to understand it's going to level out right at that y = 0. Okay, so I graphed it. Stated my asymptote. Now, I only have one transformation. What is this transformation? I have a vertical shrink. By a factor of 1/2. What's my domain? -infinity to +infinity, and my range 0 to +infinity. Y'all good with that? Okay. So for this next one, I've got f of x equals negative with 5/2 raised to the x power. So my parent function is just going to be the 5/2 raised to the x power. My x values are still -2, -1, 0, 1, 2. Okay, so 5/2 raised to the -2. So if you need to see me and how I do that, you're going to have parentheses. I'm going to type it with my parentheses just so I don't have any errors. That gives me 4 over 25. So, as a decimal, that gave me not that. That's going to give me 0.16. I'm going to go up and change that to a -1. Just going to flip it 2/5, which is 0.4. 5/2 to the 0 is 1. 5/2 to the first is just 5/2, which is what? As a decimal, which is what? Yep. And then 5/2 to the second power. Again, if you want to leave it as a fraction, that's fine. But when you're graphing that, you might want to know where that's going to end up. So that's going to be 6 1/4, so that's just 6.25. Okay, what's my only transformation that's going to happen here? Reflection over the x-axis. But in my table, I'm just going to have x and then -y. Okay, so it's just going to make all of those negative. So -0.16, -0.4, -1, -2.5, -6.25. So am I having a growth or decay? What's the value of 5/2? 2.5, which is more than 1, right? So that's actually still going to be a growth. When that base is more than 1, that's a growth. I'm reflecting it, so it looks like it's going to be a decay because I'm going to be going down, but really I'm not. It's just reflecting over that axis. It's still not going to be considered a decay. Make sure you have your asymptote, which did not change because I didn't shift it up or down. Only when you shift it up and down is it no longer going to be 0. Okay, so my horizontal asymptote is still going to be y equals 0. And then we said it reflects over the x-axis. What's my domain? Negative infinity to positive infinity. Now my range this time is going to be what? Negative infinity to 0. So you're going to have to be careful when you have a fraction here. The value is more than 1, so that's what still makes it a growth. Don't let your transformation of reflecting it confuse you. You're good? Okay, so if I'm looking at my next function, f of x equals 4 times 2 raised to the x minus 1 power minus 3, what's going to be my parent function that I'm going to be doing my y values for? 2 to the x. So 2 to the -2 we said was 1/4. Then you have 1/2. Then you have 1, 2, and 4. Now, I need to look at my original function. I've got 3 transformations happening. what's happening to my x? In my table, I'm doing x plus 1. So I'm really doing what there? That shifts where? Right. Trying to let y'all identify that because you've got that section on your worksheet. It's going to shift right 1. And then what is this 4 going to be doing? You're multiplying it by the y, and that makes it a stretch, vertical stretch. Make sure y'all put the vertical. Vertical stretch by a factor of 4. And then what else do I have happening to my y? It's going to go down 3. So negative 2 plus 1 gives me a negative 1. Then I'm going to have a 0, 1, 2, and 3. 1/4 times 4 minus 3 is going to give me 1/2 times 4 minus 3. 1 times 4 minus 3. Just 1. 2 times 4 minus 3. 4 times 4 minus 3. 13. Okay. Now, is my horizontal asymptote still going to be 0? No. What is it? This negative 3 right there is now going to be my horizontal asymptote. So it's now going to be here at negative 3. So I'm going to go ahead and draw that. You've got to look for that before you start doing your graph so you know what not to cross. .313 is going to go off my graph. I'm just going to put it up here. So if you didn't pay attention to where your horizontal asymptote is, you aren't seeing enough leveling out. So you've got to look for that adding or subtracting behind your base raised to that exponent so you know where you should be leveling out. If you don't catch that, you might miss that whole concept. So is that a growth or a decay? How do I know that? 2 is going to be greater than 1. We said our horizontal asymptote was y equals negative 3. We said we had a vertical stretch by a factor of 4. And it shifts right 1 unit and down 3. Is my domain ever going to change? No. Negative infinity to positive infinity. My range, what's my range going to be for this problem? It's going to be now negative 3 to positive infinity. That horizontal asymptote is going to affect your range. Y'all good with that? Alright, so let's just, I think y'all know how to do the graphing and the tables, okay? Let's just talk about what would happen. So, would this be a growth or a decay? It would be a decay because 1/2 is between 0 and 1. Okay? What would my horizontal asymptote be? Y equals negative 2. Make sure you have y equals when you do it. Okay, what are my transformations going to be? A vertical stretch by a factor of 3. What else? Where does it shift? Left 1 unit, and down 2. Now my domain, I know, is going to be negative infinity to infinity. Okay, it's a decay. So that means starting off and then it's getting really small. Okay? My horizontal asymptote is negative 2. I'm not going to ask you to do domain and range in the section where you do your transformations, but we are in the graphing section, so I want to see if we can analyze that. If it's going to be going like this, all the way down to negative 2, what's my range going to be? Negative 2 to positive infinity. Now, if it would have had a negative, and I reflected it, then it would have been a negative infinity up to negative 2. Okay? So you're only going to have to do domain and range when you graph it, but it's good to be able to visualize that. But can you all do that section without graphing? Are good? Okay. So we're going to do that here also. Is this going to be a growth or a decay? It's going to be a decay. What's my horizontal asymptote going to be? Y equals 3. What's my transformation going to be? It's going to reflect over the x-axis, because really what would be happening is that is going to your y. And then you got that plus 3 that's going to be tacked onto your y also, so that tells me it's going to shift where? So my domain would still be negative infinity to infinity. Now, I have a reflection here. So what do you think my range is going to be? Negative infinity to 3. Yes. Y'all good with that? Y'all have any questions? Okay, we're going to stop there before y'all go to lunch. For exponential and growth and decay models, when a real life quantity increases by a fixed percent each year or another time period, the amount y of the quantity after 2 years can be modeled by this general equation. Y equals a times 1 plus or minus r raised to the t power. So the plus or minus, if it increases, you're going to have a plus. If it decreases, you're going to have a minus. Your increase is going to be growth. Your decrease is going to be decay. It's the only difference between growth and decay for these problems. R is your percent, but when you plug it into the formula, it has to be a decimal. So you have to convert that from percent to decimal. So hopefully y'all remember that from percent to decimal, you move the decimal place to the left. Okay? The quantity 1 plus r or 1 minus r is the growth or decay factor. Alright? So you're going to have word problems. You're going to have to identify those certain characteristics, and then we're going to build the equation, which is very simple. So in 1996, there were 2,573 computer viruses and other computer security incidents. During the following 7 years, the number of incidents increased. So that automatically tells me it's going to be a what? Growth. By about 92% each year. So we have to identify the initial amount. So in your formula, A is your initial amount. I skipped over that. Sorry. A is your initial amount. So here, my initial amount is what in this problem? 2,573. Now, my percentage, my R, is 92%. But that's not my growth factor. my growth factor I said it's a growth, so it's 1 plus r. So it's going to be 1 plus, change that percent to a decimal, so it's going to be 0.92. So my growth factor is going to be 1.92. Okay, my percent increase, I already wrote, is 92%. So now we just have to plug that in. So my equation, y equals A, which is 2,573, times my 1 plus r is that 1.92 raised to the t power. So my first part is going to be a general function representing that situation. And t are the years, that's the years after 1996. Then I'm going to give you a specific value, or I might not, but if I give you a specific value, then you show me in the next step plugging it in and what does that equal to. Okay? So it says, then find the estimated number of incidents in 2015, round to the nearest whole number. Well, you've got to pay attention. When I'm talking about years, I'm giving you a specific year. My t is the year after, all the years after 1996. So if I'm going from 1996 to 2015, what's my t now? 19. My t is going to equal 19. So I'm going to find how many incidents after 19 years. And we're going to round to the nearest whole number. So you can type that exactly as you wrote it in your calculator. 2573, parentheses, 1.92, raised to the 19th. And you get that. So you're going to have 621,102,292. Are good with this? Okay. You would have learned exponential growth and decay in Algebra 1, but that's at the end of the year. Like, I do that in Unit 10. Typically, that's after spring break, so I'm not going to think that y'all learned that. I don't know. Y'all syllabus is, I don't know what they do, but I'm not assuming that y'all already know this, okay? But this is something that we cover in Algebra 1. So, a new snowmobile costs $4,200. The value of the snowmobile decreases by 10% each year. So, is that a growth or a decay? So, what's my initial amount? What's my A value? 4,200. All right, my percentage, my R, is what? 10%. So I'm going to now have a decay factor. So if it's decaying, I'm really doing 1 minus R. So I'm doing 1 minus 0.10. So what is that going to be? 0.9 or 0.90. Okay, so to write the function, I've got y equals my A, which is 4,200, times my 1 minus R was 0.90, raised to the t power. Then I'm going to find the value of the snowmobile after 5 years. So there's my t. T is going to equal 5. Plug that in. And then type that in your calculator. You're going to round to the nearest dollar. So you should get what? You're good with that? Okay? Now the next one says the value of a snowmobile has been decreasing by 7% each year since it was new. After 3 years, the value is $3,000. Find the original cost. So you're now trying to figure out what A is. Okay? So I know that I've been decreasing. So that tells me, do I have a growth or a decay? Decay. And my rate is at 7%. So my decay factor, I'm just going to do DF for time. My decay factor was supposed to be 1 minus R, which is 1 minus 0.07, which would be 0.93. So I might not know my original, but I do know my final, which is my Y. So I can set up my equation. 3,000 is equal to A times 0.93. And then what's my T? So what I can do is I can just divide both sides by that 0.93 raised to the 3. I'm not even going to evaluate that yet. I'm just going to type that 3,000 divided by 0.93 raised to the third power in my calculator. Now remember, you're talking about money. Think about that when you are rounding. What do you get? So that is the original cost. Are you good with that? These are not difficult. Okay, then we're going to talk about financial things. So compound interest. That's interest paid on the initial investment, called the principal, and on previously earned interest. Interest is horrible. When you start paying things out when y'all get older, it's horrible. So interest paid only on the principal is called simple interest. Okay, we're going to talk about simple interest, and then we're going to talk about, you're going to talk about the different ways you can compound the interest, and then we're going to talk about compounding continuously. Okay, so your formula here, now I'm not going to give you these formulas, so you're going to have to know the y equals a times 1 plus r, 1 minus r raised to the t is not hard to memorize. This is where you've got to put some effort into memorizing. It's very similar to it, except your r, you're now dividing it by n, which is the number of times you're compounding, and then you also have your n up here with your t, so you've got to remember that. So your p is your principal, which is your initial amount. Your r is your interest rate, expressed as a decimal in your formula. Your n is the number of times compounded, so you can have annually, semi-annually, quarterly, and monthly. There are also times where you can do weekly, but I'm not giving that to y'all. So annually would be 1, semi would be 2, quarterly would be 4, monthly would be 12. Okay, those hopefully would be common sense to y'all, like putting the two together. Your T is your number of years. Your A is your final amount. Okay. Now, if you are compounded continuously, that's a different formula. That's A equals P times E raised to the RT power. Okay? So, your P is still your principal, which is your initial amount. Your R is still your annual interest rate. Your T is your time in years. Okay? So, if we look at this one example, you'll take that one example and see the difference between compounding quarterly, monthly, and continuously. So you deposit $4,000 in an account that pays 2.92% annual interest. Find the balance after 2 years if the interest is compounded. So quarterly will be what we do first. So my principal, my p-value, my initial amount is that $4,000. My R is 2.92%, but as a decimal, that's going to be 0.0292. My T is 2 years. So quarterly, my N is going to be 4. So I'm going to have A is equal to my 4,000, that's my P, times 1 plus, I'm dividing 0.0292 by my N, which is 4. All raised to the NT power. So I'm going to have 4 times 2. Okay, so when you type that in your calculator, you have to be very careful when you're plugging that in. So I've got 4,000 parentheses, 1 plus, I'm going to go ahead and do the fraction template so that everything looks the exact same way I wrote it, and then you're less likely to make mistakes. Now, you don't have to do the 4 times 2. You obviously know that that's 8. You can raise it to the 8th power when you're typing it in. So that gives you 4,239.66. So it's good when you're investing to have interest, but when you're paying stuff like a mortgage, interest is not your friend. So if I was doing monthly, my N is the only thing that changes, and that's going to change to 12. So I'm going to have that whole thing, 4,000 times 1 plus 0.0292 divided by 12, all raised to the 12 times 2 power. So I've already typed it in. I'm just going to go grab it and change the 8 to a 12. You got to change the 4 to the 12 too. My bad. Yeah. Yes. Yes. There we go. Sorry. So 4,240 and 26 cents. Then continuously is the A equals P times E to the RT power. So I'm going to have 4,000 times E, your R, 0.0292, times your T, which is 2. So on this calculator, to get to your E, I'm going to already have my 4,000. You're going to see that log under the percent. It's in gray, so I'm going to have to do second log. Go over to LN. Y'all are about to learn that that's natural log. That's going to be our next lesson. But see that E? That's how you get there. And then you're going to multiply 0.0292 times 2. I do that in parentheses. So you get 4,240.56. And that's it. So you just have to know your formulas. If you don't know your formulas, obviously you can't do the problem. Okay? You have any questions? To get to E, you're going to do second log, then go over to LN, and it's the second one.